Alright guys, so here's the question about Hess's law, problem set 27, question 7. It says calculate the delta H naught, or change in enthalpy at standard state conditions for the reaction of this using the information below. And then we're given all these smaller reactions in their delta H naught values. So remember, Hess's law basically is, you're going to want to look up the definition from the slides or the book in case you're asked a more conceptual question on it. But in applied terms, it's for a reaction that we don't know the change in enthalpy of, we can figure it out or get a pretty good estimate of it by taking smaller reactions that we do know the change in enthalpy of and adding them up and flipping them around in order to get the bigger reaction that we're looking for. So I wrote down some steps. If you need, you can take a picture of them, you can write them down neater. I just wrote these down real quick. But first we get the reactants and products on the correct side of the equation. So reactants on reactant side, meaning these reactants, we want to find those reactants, we want to get those reactants from these reactants on the correct side, and same with the products on the correct side. And remember, we flip the arrow and we flip the sign of the delta H value. And then we're going to add up all the reactants and all the products. Third, we're going to cancel out anything that's found on both the reactants and product side. And then fourth, we're going to check the number of moles of each product and reactant that we have and make sure we have enough or how much we want. And we can multiply equations by a number in order to get the number of moles we need. And I can't remember any ones that I've divided the equation by an amount, but I could totally see that happening. But we won't be dividing on this question, so alright. I might have to split this up into 2 videos because this is a long process. So what I do every time is I take the equation highlighted and I actually rewrite it down here, just to make it easier to look at so I don't get lost myself. You can do it however you want, but so first I'm going to look at my given equation and make sure I have everything on the correct side that I want it. So first thing is C2H4, right? If we look in this whole process, we only find C2H4 in this third equation, and it is on the product side. We want it here on the reactant side. And so what we're going to do is cancel out this arrow and draw it going the other way. Now, I used to redraw the whole this little equation so I didn't get it mixed up, but I've done them enough now that I don't. So feel free to do it however you want. But so we have that done. Now we need F2. Now if we look, we have F2 in the first and second equation. This is on the reactant side, and both of these are on the reactant side as well, so we're good there. We don't have to change anything. Then we have CF4, and it looks like the only CF4 we have is right here, and it is on the product side, and that's what we want, okay? Then we have HF. It's the only HF, the H and the F together that we have. And we're not going to be counting H2 and F2 or something, but just HF, okay? So we're good on, we've done all the arrows, but remember, I even almost forgot, because we switched this arrow around, we have to change the sign of the delta H value for this reaction. Sorry, there should be not right there. I had to remake all those delta H signs because the copy and paste didn't work. But so everything is in the correct order. So we got everything on the right side. We flipped the signs, and now we're going to add up the reactants and products. Step 2. So we're going to add up all of the reactants. And remember, this is no longer the reactant. It's this right here, okay? And we're going to get H2. For time's sake, I'm going to ignore the gas, like liquid, the phases, the states. But in the test, you're going to want to draw those. H2 plus F2 plus C plus 2F2 plus C2H4, okay? And then let's erase that. Now we're going to add up all of the products. So remember, this is the product now, and then these two, okay? So we have 2HF plus CF4 plus 2C plus 2H2. Okay, so we added that up, but now part of adding up, don't move on to step 3 yet. Part of adding up is looking and seeing we have F2, we have 2 F2 molecules, so we're going to add those together. And over on the product side, it looks like we don't have anything of the same. So, I mean, I just do this so I don't mess up. You don't have to. But, so, H2 plus, that's 2F2 plus 1F2. 3F2 plus C plus C2H4 goes to 2HF plus CF4 plus 2C plus 2H2, okay? So here, now we move on to step 3. Cancel out the same compounds, or I should put elements, whatever, say molecules found on both sides of the reaction. So here, let's look. I have H2 and H2, okay? So here I have one H2. Remember, there's a 1 in front of there. And here I have 2 H2. Now, I'm only going to be able to cancel out this entire H2 molecule, but I will only be able to cancel out one of these H2s. So I'll still have an H2 left here. So H2 will be in my product. Let's see, I have F2. I don't have an F2 on that side. The only